Alrighty, let's talk about objects in our solar system. Okay, so the Alright, so in our solar system we have our sun, we have our planets, and then we have other objects like asteroids, comets, meteors, dwarf planets, moons, stuff like that. The asteroids, comets, and meteors are considered small, and I say small with quotes because things are kind of relative when you think about size. The larger ones would be your things like planets, moons, and dwarf planets. The order of our planets goes as follows. You have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Mercury is the one closest to the sun, Neptune is the one farthest away from the sun, and you can remember the order by saying, "My very educated mother just served us noodles." We're not going to go into super big detail about what each planet is like, but I would know the correct order of them. So we've talked about light years before. We also use another unit called an AU, and an AU stands for astronomical unit. So an AU is basically the average distance of how far Earth is away from the sun. It's about 93 million miles or 150 million kilometers. And so when we're talking about distances that are smaller than light years, but like bigger than, your hundreds of thousands of kilometers or whatever, we would use the term AU. So we are 1 AU away from the sun. Mercury would be less than AU. Neptune would be more than AU. And we've already talked about light years, so I'm going to skip that. Alright, so when we orbit our sun, we do not orbit in a perfect circle. We orbit in something that is called an ellipse, which is basically an oval that is almost a circle. So it is technically an oval, but it is very close to a circle, just not a perfect circle. So again, we orbit in an ellipse. And there are two forces that help us balance out in space. So think back to Newton's laws for a second. Everything that has mass also has gravity, and we also have inertia. And we want both of those things at the same time, because if we just had gravity, we would crash into the sun, and it would not be very good for us. So gravity keeps us gravitationally attracted to the sun and prevents us from flying off into space, and inertia allows us to not crash into the sun. So remember, inertia is an object's tendency to keep moving in whatever direction it is already moving. So like my laptop sitting here on my desk, it's going to stay there unless I put a force on it, but if I kick a ball, that ball is going to keep rolling until something stops it. So with our planet moving, if gravity all of a sudden turned off, we would fly out into space in whatever direction we were originally heading in because of inertia. So again, gravity keeps us attached to the sun, but inertia keeps us from crashing into the sun because they're working kind of in opposite directions. So we want both of those things together at the same time. All right, so how exactly did our solar system form? So think back to our Big Bang Theory notes. Whenever the universe originally exploded, just by random chance, you had random particles colliding into each other. So maybe a little speck of dust with a little bit of gravity and a little speck of dust with also a little bit of gravity randomly crashed into each other. Well, now those two specks together have a bigger mass, they have more gravity, and they gravitationally attract another speck of dust. And now it has even more gravity, and so on and so forth. Basically, that process happens over and over again until you have something really big, like a planet or a star or an asteroid or dust or gas or whatever. So that's basically how our solar system forms. We have random chunks of things that are colliding together, getting more gravity, they attract more things, and then you end up with things like planets and stars and all of that fun stuff. Alright, so let's talk about actual objects. So if you orbit around something that is not a star, like if you're a rock orbiting around a planet, you are considered a moon. Now, moon is a general term. Like Saturn has a bunch of moons, Jupiter has a bunch of moons. Earth only has one moon, and our moon is a moon with an uppercase M, because our moon's name is just moon. But if we're talking about moons on other planets, they are lowercase moons, and they have actual names. Like Titan is one of the ones from Jupiter, I think. It's Jupiter's moon's name is Titan versus our moon's name is just moon. Super creative. We're going to talk about orbits. All right, so dwarf planets. People like to argue about dwarf planets all the time. Here's what constitutes a dwarf planet. We have 5 right now. We have Pluto, Charon, Ceres, Dysnomia, and Eris. Hopefully I pronounced those correctly. If you are a dwarf planet, that means you do not clear your orbit. And here's what that means. So, take Earth for example. When we orbit around the sun, we have our own predetermined path, and nothing else crosses our path. We are not sharing our orbit with any other planet, anything else. Dwarf planets do share their orbits with other things. So, like at some point, Pluto and Charon might cross paths. That doesn't necessarily mean they're going to collide, although I guess they could technically. But they do not have their own independent orbit. If you imagined it like driving on a highway, Earth has its own lane, and no other car will ever get in our lane. But if you're Pluto, other things are going to get into your lane from time to time. That is the main difference. So again, dwarf planets orbit the sun. They have enough mass to be round. When you get fat enough, you're round. That's why Earth is round and all the planets are round. However, it has not cleared its orbit, meaning it is a dwarf planet. If you are round enough, if you have enough mass to be round and you clear your orbit, you are a regular planet. But if you do not clear your orbit, you are a dwarf planet. Alrighty, so let's talk about asteroids. Okay, so you have asteroids, meteoroids, meteorites. They all sound very similar, and they basically are the same thing. However, their name depends on where they are located. So if you have a huge rock floating out in space and it's not big enough to be round, it's an asteroid. And these are usually rocky, iron, carbon things. And then most of them are located in the asteroid belt between Mars and Jupiter. I'm going to go back to comets in a minute. If you have a small chunk of asteroid or a little piece of asteroid, it is a meteoroid with the IOD at the end. If you have an asteroid or a meteoroid that comes into Earth's atmosphere and starts to burn up like a shooting star, that is a meteor. And if that chunk of rock survives and actually hits Earth's surface, it is a meteorite with a T. So again, all basically the same thing, just at different stages. If you have a big rock in space, it's an asteroid. If you have a small rock in space, it's a meteoroid. If it's crashing through our atmosphere and burning up like a shooting star, it's a meteor. And if it survives and hits Earth's surface, it is a meteorite. Now, going back to comets. Comets are giant chunks of rock, dust, and ice. And what happens is when they get close to the sun, all the gas and ice on them starts to melt, and it gives them that pretty tail. One example is Halley's Comet. It takes about 76 years to orbit the sun, and we can see it every 76 years or so, and you see the pretty tail as it gets closer to our sun, and they're often called dirty snowballs. Your asteroids and your meteoroids and stuff are generally not going to have ice on them, and they're not going to have that pretty tail. All right. Hope that makes sense.